So again, we'll look at these. We're going to decide whether they're equal in area, whether A is bigger or smaller in area, or whether B is bigger and smaller in area. So we've decided, Linus, you said that they're equal, and that is correct. And now we're going to go through how we got to that thought process. So we've got this little square that sticks out right here on this one. So if we had measurements, we could measure it. Say if this side was 1 and this side was 1, we could measure that against this square right here. So if we did, we could cut this out, move it over, and it would fill in the hole exactly. And then it would look like A right here. So that would mean we could move B and put it over top of A, and it would be exactly the same. You would be able to cover it up and it would match exactly. So they would have the same area, which means they're equal, like you said. So on the next slide, what we talked about last week, kind of the big idea of this lesson is that, like we did last week, you can decompose a shape and then rearrange the shapes to determine what the area was. So like we said in figure B, we removed that little square or decomposed it and then rearranged that square. We'll go back. We removed this little square in our minds, and we have to do this in our mind. And then we moved it and covered up this square, and it fit in that little hole perfectly. So then we determined that this shape matched this shape exactly, which means that they have the same area. Okay, computer, come on. There we go. So like I said, we can decompose it and rearrange it so it matches up exactly with the two figures. So what that means, like we said, when two figures that are put on top of each other and they match up exactly, we know that those areas are the same. So we're going to look at some examples. So in this example, each grid square is 1 square unit. So we're going to find the area of each shaded region, which is the blue area, using a different method besides just counting. So we will go through that. So here we've got this weird, funny looking shape. So we're going to decompose that to find the area. Well, let's go back. Where's my little laser? Oh, I'm sorry, Linus. I'm still figuring this thing out. Okay. So do you see any, think we could break this shape down any, Linus? Instead of looking as kind of an L shape, do you think we could break it down so they look more familiar to you? Let's try this.
Yes.
We've got maybe like so. I know my drawing skills aren't very good, but does that kind of look like a rectangle?
Yes.
And what do we have here on this side? Does that kind of look like another rectangle?
Yeah.
All right, so that looks a little more, well, not, don't look at my drawing necessarily, it's not very good, but this looks a little more familiar than that first L-shaped square. So it makes it a little easier to find the area of this entire shape if we break it down into more familiar shapes. So let's look at this one here. If we count the number of blocks within this one rectangle, we can get the area for that one. So let's count these blocks right here. We've got 1, 2, 3, 4, 5, and 6. So what would the area of that rectangle be?
6.
6, that's right. All right, so let's keep that in our mind, 6. Let's look at this one here. So let's count these. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So what would the area of that rectangle be? 18, that's right. So we've got the area of this one was 6. The area of this one was 18. How do you think we would find the area of this entire shape? Add them together, that's right. So what we've got 6 plus 18. So what would that be? It's okay. You need some help. I'll help you out there. What's that? 24, that's right. So we got those, like you said, by adding these two areas together. So good job. So let's look at another one. On this one, again, each grid square is 1 square unit. So we're going to find the area, kind of breaking it down like we did with the last one. So let's look at this one again. So this one, you see this, we're going to look at the blue shaded area only. So we've got this white square in the middle that kind of messes everything up. So how in the world are we going to find the area of the blue part? Well, we'll break it down again. So we can break it down into rectangles again. So let's try this here. Again, I'm sorry, my drawing skills are not very good. So we can do, here I'll just use a different color. And we've got this one here. And break it down into this one here. So what we're doing here, remember we're taking this apart into different shapes. We're breaking it down. Another word for that would be to decompose. So then lastly, we've got this here. All right, so how many rectangles do we have there now? Instead of just one weird looking one with a hole in the middle, how many do we have that are in the different colors here?
1, 2, 3, 4.
4, that's right. So let's do like we did on the last one. Let's count the number of squares in the red rectangle. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So what would the area of that rectangle be? The red one.
12.
12, that's right. So let's look at the blue one here. Can you count those squares for me?
1, 2, 3, 4.
4, that's right. So what would the area of that rectangle be?
4.
4, good job. All right, 2 more. What about this green one? Can you count those for me?
1, 2, 3, 4.
See the green one here?
1, 2, 3.
3. So what would that area be?
3.
3. Good job. So the last one here, let's see the yellow one. Let's count that one together. 1, 2,
1, 2,
3, 4,
4,
5,
5,
6,
6,
7, and 8. So what would the area there be?
8.
8. So let's add all those together. We've got 12 here in the red one, 4 here in the blue one, 3 in the green one, and then 8 in the yellow one. And I'll just add that for you since I can't really write on here. So that would be Huh?
27.
27? That's right.
Yeah.
So I didn't need to do that for you. Good job, Linus. That's exactly right.
How many is a calculator?
Oh, calculators. I forgot about those. Oh, good job, though, Linus. Awesome job. All right, we'll look at another one here. And just like the last ones, each little square is one square unit. Well, I can't draw on this, so this one may be a little difficult. Well, we'll look at it. We're going to look at some triangles this time, okay? So again, each little blue square is one square unit. So we're going to try to find the area. So I'll tell you what I'm going to do. You see the blue shaded parts here? What kind of shape does that look like?
Sorry.
What is this shape right here?
Triangle.
That's right. So we've got 4 triangles in here. They're all the same size. So if I were to ask you the area of this shape, it would probably be a little difficult just to look at this and determine the shape. One reason is because it's kind of an odd looking shape. Another reason is we can't just count the number of squares in here. So we have to break it down again. And what is it called when we break a shape down? You remember?
Triangle? No.
We decompose it. And we'll keep learning that word as we go on. I know it's a hard word to learn, but we'll keep learning that. So how do we figure out the area of these triangles? We can't count them. So what do? We break it down like we said, but then we're going to need to rearrange the triangles. So if I could, I would just pick this triangle up, the green one for instance, and move it over here. And then we can make a new shape that we're more familiar with. So let me kind of show you what I mean. So we're going to work with this green triangle and this red one here. So if I were to decompose, which we've already done, we've broken them into different colored triangles, we could rearrange it. And what I would do, I'll pick this triangle up and I would move it over here. And then we could make a new shape with the red triangle. So again, my drawing is not very good, so I apologize for that. But if we were to look at this shape as a whole, right here, what does that shape look like?
Triangle.
Rectangle, that's right. So what could we do then? We could just count the number of squares inside the rectangle. So we've got, they're not all shaded now, so it makes it a little confusing, but we're going to pretend that all of the squares inside this purple rectangle are shaded because we need to know the area. So we've got 1, 2, 3, 4, 5, 6, 7, and 8. So what would the area be of that purple rectangle?
8.
8, that's right. So let's think about what that means again. So what we want to know is the area of the shaded portions. This part isn't shaded right now, but it still represents this green triangle. So now we know the area of these 2 triangles together. We did that by decomposing and rearranging the triangles into a shape that's a little more familiar to us, which is this purple rectangle. And we determined that the area of that is equal to 8. So just if you were to look at it, what do you think the area of these 2, the blue and the yellow triangle together would be? They look pretty similar to these triangles up here. So what do you think if we were to decompose these and then rearrange them to make them into a shape that's more familiar? What do you think that shape would be?
8.
Well, the area would be 8. That's exactly right. What would the shape be that we're a little more familiar with to get that egg? What do you think that would look like?
Look at your screen. It would look like that purple one.
I'll draw it out for you.
You're close.
Rectangle, that's right. That's right. So you said the area of that one was 8. So what do we think the area of the entire shape is now? Or the entire shaded part, I'm sorry. What do we need to do? We need to add those together.
2 rectangles, you're right. Use your calculator. Yeah, of course. This is 16.
16, that is exactly right. Good job, Linus. Trying to erase little marks here so we can move on. Nice job though, Linus. All right. Let's do one more. I'm going to skip this one. Oh, my computer is really slow today. All right, let's look at this one. This time we've gotten rid of the little squares. But we do know how long each side of the square is for both of them, both the blue one and the white one. So we can't just count this one to find the area of the shaded one, but we can use the same principle to find it. We can decompose, rearrange to find the area. So let's look at the big square. Don't worry, just pretend that the white square isn't there right now. If we were to look at the blue square there, how do you think we would find the area? Even though we don't have the little tiny squares in the middle. I don't know if you've been taught this yet, but we can talk about it a little bit. Have you learned about length times width yet, Linus, in the past?
Have you learned about
No? All right.
No.
Well, I'll go through this with you just so you can kind of see how we get to the area at the end. The area is going to be 21 square centimeters. Don't worry about that answer. I'll just kind of walk through the process with you, and we can get into this a little further later. But to find the area, we would multiply length times width of the big blue square. That would give us 25 square centimeters. And we also know the little white square here. We know what that would be because we know how long each side is. Those are 2 centimeters apiece. So to get the area, we would multiply length times width for that, which would give us 4. So if we wanted to find the area of just of the blue shaded part, we know the entire square is 25 square centimeters. We know that the small white square is 4 square centimeters. How do you think we would find the area of just the blue part if we were to decompose and rearrange this square? You got any ideas? Subtract, that's right. That is exactly right. So if we've got 25 square centimeters for the big one, minus 4 square centimeters for the little one, if we were to remove that little one, what would that leave us?
25.
Is
21.
21, that's right. All right, so you see how we did that? How we got there? We found the area of the big square, and then we found the area of the small square. And then we know we don't need that small square, so we just take it out, or we subtract it. And that gives us the area of the blue shaded part that we need. All right, does that make sense?
Yes.
Okay, so that's all we've got today. So again, we looked at how to decompose a shape and rearrange it to find the area, and we did that so we can make the shapes a little more familiar to us and a little easier to calculate the area. So what I'm going to do, I'm going to post a little exit slip on Google Classroom for everybody to do. Just take your time and do the best you can. And if you have any questions, please don't hesitate to reach out to me. And we will see you on Wednesday if you don't have any questions, okay?